Hello, I welcome you all. This problem is coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Hibbeler. And in this problem, we have a smooth cane and it has a mass of 3 kg. This is the cane here. And then we've been given the constant angular velocity. Then we've been asked to determine the force which the rod exerts on the cane at the instant theta equal to 30 degrees. And then we've been given the rest of the information here, R, which determines the path of this cane, and so on and so forth. Alright, so let's draw the free body diagram. So before we do so, we are using polar coordinates. So we'll have the radial coordinate in that direction, and the theta coordinate in that direction, like so. Right. Okay. So we have at this point, let's say this is going to be my point where the cane is tangent to the surface. So at this point we are going to have normal force. So let's say that is the point where we have normal force. So we have normal force there perpendicular to that line, tangent line. Alright, and then here we do have a force, okay, perpendicular to the arm, right? Okay, something like that. And then we also do have the weight, right, like so. And then we are going to have components. We'll have components of the normal force, like so. We have one there. Maybe this one is not good enough. Let's choose blue, maybe it will stand out. Okay, there we go. We do have components. This one is components from the normal force, and then we do have additional components from the weight, like so. Okay, and then we do have the angles. Let's define our angles. So we have this angle here, and this is psi, and then we'll call this angle here is our alpha. Okay. So we have W, and if this one here, let me define some more angles. I define some more angles. So if this one here is theta, if this is theta, of course this becomes 90 minus theta, and this one becomes theta, right? Great. So this one here is theta. Is that fine? So if that is the case, then we'll have this one as W sine theta, and this one is W cos theta. Okay, then this one is our normal force. Okay, so we are going to have components. So we have this one. This one is n cos alpha, and this one is n sine alpha. Okay, and this one is our force. This is our force. Great. What else do we have? I think this is about it. So let's define these angles and everything. So psi itself, tan psi is just equal to r divided by dr d theta. Okay, and then our r is just going to be equal to r is equal to r is equal to 1.2 cos theta, and dr d theta is just equal to minus 1.2 sine theta. Alright, so we have tan psi is just equal to 1.2 cos theta divided by minus 1.2 sine theta at theta equal to 30 degrees. Therefore, psi, making psi subject to the formula, of course, this and this cancels, and then we have cos 30 divided by sine 30, tan inverse of that. This gives us a 60 degrees. Okay, in fact a minus 60 degrees, right? Minus 60 degrees, which just simply means our psi is just equal to 60 and we are moving in the clockwise direction. Okay, right? So cos 30 divided by, okay, and tan inverse of that's minus 60. Alright, which is clockwise. Alright, and then our alpha is just going to be equal to 90 minus psi, okay, which is just equal to 90 minus 60 degrees, and this is equal to 30 degrees. Calm. Alright, so let's now find the other components. This one we just shorten it a little bit, and this is our r and this is our theta, and we do have our kinetic diagram in that direction and there in that direction, like so. This is our m a theta and this is our m a r. Right, so we said r itself is just equal to 1.2 cos theta. Therefore r dot will just be equal to 1.2 theta dot minus sine theta, and this is just going to be equal to minus 1.2 theta dot 1.2 theta dot 1.2 theta dot sine theta. Then R double dot, this is just equal to 1.2 open brackets. Using product rule, we do the derivative of one, we keep constant the other one, then we say derivative of the other one, this just becomes like so. Okay, all right. And then for theta itself, we do have theta itself equal to 30 degrees, and then theta dot is equal to 0.5, and it is constant. Therefore theta double dot is just going to be equal to 0. So our R at theta equal to 30 degrees is just going to be equal to, so 1.2 cos 30, this just gives us a 1.0392. 1.2 cos 30, 1.0392. Then we have R dot, okay, theta equal to theta equal to 30 degrees. This is just going to be equal to minus 1.2 times theta dot, which is 0.5, then sine 30. So this we just get a minus 0.3. Okay. So point this by 1.2, 0.3. Then we have R double dot at theta equal to 30 degrees. There we go. Of course, this part goes to 0. Then we have 0.5 squared cos 30 times 1.2. Alright, so we do have minus 0.2598. So 0.5 squared cos 30 times 1.2, 0.2598. Alright, okay, so there we go. Let's work out this stuff. So our AR is just going to be equal to R double dot minus R theta dot squared, and this is equal to minus 0.2598 minus R, which is just 1.0392 by 0.5 squared, and therefore our AR will just be equal to minus 0.2598 minus 1.0392 times 0.5 squared. This gives us a minus 0.5196. Then we have A theta. I have A theta, and this is equal to R theta double dot plus 2R dot theta dot, and this is equal to, our R is 1.0392 theta double dot is 0, okay, plus, then we have 2 R dot minus 0.3, and then we have theta dot as a 0.5. Therefore A theta will just be equal to 2 by 0.3 by 0.5, This is just a minus 0.3. Okay, so 2 by 0.3 by 0.5, 0.3 minus. So 2 by r dot theta dot. Right, so we have summation of forces in the r direction equal to MAR going in this direction. We do have N cos alpha minus W sine theta. What else? Okay, this is about it, right? This is equal to MAR. So alpha itself is 30. W is the mass for this is a 3 kg by 9.81 sine theta, and theta is alpha is also 30, and theta is 30 also. Is that so? Okay, so this is equal to 3 by AR, which is just a minus 0.5196. Alright, so there we go. So our n therefore from this is just going to be equal to 3 by 0.5196. Okay, then this is a 15.19 newtons, right? So 3 by 9.81 sine 30 minus 3 by 0.5196 and everything divided by cos 30. Alright, so once we have this, let's work out the other one. Summation of forces in the n in theta direction equal to m theta. Going in that direction being now positive. So what do we have? We do have n sine alpha plus f minus w cos theta equal to m a theta. We do have here 15.19 sine alpha, which is 30, plus f minus 3 by 9.81 cos 30 equal to 3 by minus 0.3. Therefore, our f is just going to be equal to minus 3 by 0.3 plus 3 plus 3 by 9.81 cos 30 minus 15.19 sine 30. So this gives us a 16.99 newtons. Okay, let me check it out again. Minus 0.3 by 3 plus 3 by 9.81 cos 30 minus 15.19 sine 30. Okay, and this one is in this direction like this, and the normal force is in this direction like this. Alright, I guess this is about it. Let's just outline the solution. So we have our n there like so, and then we do have our f like so. So I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and see you in my next screencast.